Database design is a very extensive subject, and I intend to build an entire course on that to do the subject justice. But we need to understand at least a few basic things about database design before we begin setting up our own tables. I want to optimize your chances of success when you go beyond our example databases for this course and into your own projects. And good database design is a key to that success. We will be dealing mostly with table design here in this introductory course, so we will set aside the complexities involved with relating tables until the Part 2 course that follows this one. Still, there are some basic principles that should be acknowledged. Database design deals first and foremost with how we combine data items or columns to define a table. As we add more tables to a database, we must consider whether a new table is related to any of our existing tables and what that relationship is. We must then consider how those related tables are to be accessed and how to manifest their relationship in the table structures themselves. In MySQL, this also involves our choice of storage engine for each of these tables. Our basic goal is to create an efficient operational structure that maximizes storage space, access time, and maintenance complexity. But this is an ideal that is nearly impossible to achieve without some compromises. So the old adage that we should pick two and be happy with that often applies. There are some basic rules for a table structure that we can apply without being concerned with other tables, though. So that's where we'll begin in this course. The most basic rule is that each column in a table should be designed to hold a single value, and that value is not derived from other columns in that table. We can always derive composite values in our result sets for a specific query, so it's a waste of space to store both the raw values and then one or more composite values derived from them. For example, in a database of people information, if we need to have separate access to the first and last name of a person, we should have separate columns for these two values. We can always combine them in a query used to print mailing labels if we need to. But we would not store the two separately and then store them combined together in a third column. That would be redundant and an obvious waste of space. If we need to be more culturally sensitive, with some people needing their family name to come first in the composite value, then we should name the columns more appropriately as family name and given name, and then have a third column that indicates whether the family name is to come first or last. This offers us greater flexibility and still saves space. We should always define a column or, if absolutely necessary, a group of columns to act as the primary key. This is a unique identifier for a given row and is defined to maintain uniqueness among the rows in the table. The primary key can be either a value from the real world, such as the Social Security number here in the US, or it can be a completely fictitious identifier, such as a customer ID made up by and maintained by the database management system itself. We will see how important this is when we get to the second course in this series, and must target a specific row for update or deletion. The table should be defined in such a way that all columns are solely dependent on the primary key value. That is, no part of a given table should be masking greater complexity in the table structure of the database. An example of this would be a single table created to store exactly the columns found on a paper form, such as an insurance application. In reality, that form is a cross-section of a number of tables, from the customer table to various lookup tables of standard values. For more on this issue, we'd have to spend more time on it, but it's not so important for this first course. This issue is most often noticed by examining the data once we have some data in the table. We would notice redundant groupings of the same values in certain columns in row after row. This is a situation we want to avoid wherever possible, as it can lead to data entry errors among other things. A design flaw that is much easier to spot is repeating groups of columns, another thing we need to avoid. The occurrence of repeating columns in a table's definition is a clear indicator that another table or two are required in our design. For example, an invoice table that contains groupings like product 1, quantity 1, price 1, and then product 2, quantity 2, price 2, and so on, indicates that not only should we have a separate product table from which to look up and verify our product codes, but a line items table related to both the product and invoice that gives us a more flexible structure for reporting purposes. We will discuss this in the next course where we deal with multiple table issues. Rules like these have been canonized into a principle of database normalization long ago. The rules of normalization make a great cross-check for us as we design our tables, but beware of reference sources that suggest that normalization should be used as a primary step-by-step design technique. That can quickly lead to errors in database design, especially when the designer is not intimately familiar with the data being mapped into the database. Again, more on this subject in my database design course. When we get to the next course involving multi-table operations, the subject of relationships between tables will come up. Here are the 4 logical relationships that there can be between 2 tables. Understanding these relationship types, plus understanding that there are also structural and operational aspects to them, is beyond our needs in this course though. Here we will only be dealing with single table operations where there are no relationships to be considered. In the Part 2 course we will go into this a bit further, but not to the extent that the dedicated database design course will. Another important aspect of a table that can make it more efficient is the group of indexes we establish for that table. The next lesson describes what an index is and how it is used.